Hi everyone. I hope that you're all healthy and safe. And if so, I hope that you're bored enough to find my videos appealing. Today we're going to finish section 3.3. We left off with the polynomial 5x to the fourth minus 17x cubed minus 21x squared plus 59x minus 14. And we'd already found Cauchy's bound and used the rational zeros theorem to list all the possible rational zeros. But I'll kind of start from scratch just because I know, it's been quite a while since we've had class, and I'm guessing that many of you haven't looked this over, right? So first what we did is we found Cauchy's bound, which gives us a bound that guarantees that all of the zeros of the polynomial fall between two numbers. That means that we know exactly where the x-intercepts can occur. And the way that we find this is we look for the largest number, the largest coefficient, ignoring the leading coefficient, okay? So look for the largest value. Don't pay attention to the signs for this, okay? What's just the biggest number that you see? So in our case, the biggest number that we see is 59. Okay, so we take 59. What we want to do is divide it by the leading coefficient. So we divide it by 5. We want to make sure everything here is positive, right? I said to ignore the signs, but we want to make sure it's positive. So I'm going to take the absolute value of this. And then we add on 1. Okay, you always add 1. So if we work this out, I'm going to use a calculator here because I'm just going to get a decimal approximation for this. So I'm going to take 59 divided by 5, which is 11.8. And that's already positive. So the absolute value would just keep it positive, right? So we have 11.8. We're going to add 1. We have 12.8. So what that tells us is that all of the real zeros of our polynomial lie within the bound from negative 12.8 to positive 12.8. So those are x values, right? So the zeros need to lie between those two numbers, which really is kind of cool because it narrows it down, right? It takes... Initially, we have no idea what the zeros are, where they're at, so it could be anything from negative infinity to infinity. Now this narrows it down to negative 12.8 to 12.8, which seems much, much smaller, right? So that's pretty cool. And that does help us with knowing, and if we're going to use a calculator for this, what can we set our calculator x values to be when we look at the graph? And now we know negative 12.8 to 12.8 is a good choice. Okay, so we'll keep this in mind. Next, what we did is we used the rational zeros theorem to figure out what are the potential rational zeros of the polynomial. And to get that, we had to list factors of the constant term. Ignore the signs again, okay? So factors of 14. And we also had to list factors of the leading coefficient. So we had to list factors of 5. All right, so factors of 14, that means, what divides into 14 evenly? We have 1, 2, 7, and 14 itself, right? What divides into 5? 5 is prime, so only 1 and 5. So our possible rational zeros are going to be every combination of the numbers that are divisors of 14 divided by the divisors of 5, okay? So if we go through this, we get 1 divided by 1, 1 divided by 5. 2 divided by 1, 2 divided by 5. 7 divided by 1, 7 divided by 5. 14 divided by 1, 14 divided by 5. All right? And plus or minus actually on all of those, okay? So we get plus or minus 1, plus or minus 1/5, plus or minus 2, plus or minus 2/5, plus or minus 7, plus or minus 7/5, plus or minus 14, plus or minus 14/5. And there we go. So there's all the possible rational zeros that you see listed here. And at that point, we have to pick which of these will actually work, right? And if you didn't have a calculator, you would actually have to sit here and you would have to use synthetic division maybe with all of these. And what you would look for, if you divided our polynomial by these with synthetic division, you'd want to figure out which one had a remainder of 0. That'd be a lot of work though, potentially, right? Unless you got really lucky. So I'm not going to make you do that. Although after class, after I taught this last time, Kristen came up to me and she said, when I was in high school, I had a really good math teacher, and he actually made us go through, and he called it doing their P's and Q's, and he made them test out all of these values by hand with no calculator. And I thought maybe I should do that to all of you. But then I decided against it. All right, so here we go. What we're gonna do is graph the polynomial. Actually, this is kind of funny. So look, a lot of crazy stuff going on in there. That's because I let my 2-year-old play with my calculator. Okay, so we're gonna zoom out. I'm gonna go ahead and delete this stuff. And we're gonna type in the polynomial, 5x to the 4th minus 17x to the 3rd minus 21x squared plus 59x minus 14. All right, there you go. And I hope that you guys are following along with this. So we're gonna graph this. I have a weird window. So you know how you fix a weird window? You hit zoom 6. All right, there's a 10 by 10 window with this graph there. Now what I'm gonna do is try to figure out, okay, you can kind of look at the graph and guess where the graph is crossing the x-axis, and then you wanna choose from your list of numbers here. But you wanna make sure you hit trace first. So hit the trace button right here. And then you can type in potential answers, right? So I remember from class what actually worked. Looks like -2, actually I can see here. -2, okay, yeah. So -2 does work. See how the cursor's on there? -2, 0. All right, I'm gonna write that down there. X equals -2 works. What else works? I don't remember, so I'm gonna have to try this out here. Maybe it was 2/5. No. Was it 1/5? Nope. Was it 7/5? Yes. 7/5 works. All right, and because our polynomial was a 4th degree, since we found 2 of the zeros, once we do synthetic division with both of them, it will then reduce the polynomial down to a quadratic factor that we have left over, and we can find the rest of the zeros from there. So we're in a good position right now. So we have those 2 numbers. What we're gonna do now is do our synthetic division. I'm gonna go ahead and erase what we have so far, and then go ahead and start with the synthetic division so you all can see it well. This is a cheap board, and earlier it wasn't erasing very well, so hopefully it works out a little bit better right now. Let's see. Get rid of this. Ooh. did okay, right? I think it was all right. So we're gonna set up our synthetic division. I put -2 in the box. And then we're gonna line up our coefficients. We have 5, -17, -21, 59, and -14. I'm gonna leave a space. We're gonna go ahead and bring down our first number, then multiply, you get -10, then add, you get -27, and then multiply, you get 54. Is that right? And then add, you get 33. And then multiply, you get -66. And then add, and you get -7. And then multiply, and you get 14. And then those cancel out, which is what we want. All right, yay for mental math. Now, we go ahead and use our other 0 that we found, which was 7/5. And we repeat this process. Okay, sorry about the glare that I have there from my my light. I might have to relocate next time I shoot a video. Okay, what we're gonna do now, right, is bring down the 5, and then we're gonna multiply. 7/5 times 5 is 7. Add, you get -20. Multiply, you get -28. Add, and you get 5. Multiply, and you get 7, and then those cancel out again. Just good news. All right, I can erase this. I just kept that there so I could remember what I was doing. So next, we're gonna go ahead and put the variables back into the equation. So since we divided out twice, we started with x to the 4th. We're now down to x squared. So we'll have 5x squared minus 20x plus 5 equals 0. And now we just have to solve that, which we should know how to do because, hey, it's a quadratic equation, which means we can always use the quadratic formula, right? That's always a tool that's great, and I know a lot of you like to use it. If you want to, you could try to see if it factors, right? That's usually what I do. I try to see, could it maybe factor? So we're gonna go ahead and try that. Actually, all these numbers are divisible by 5, so I can divide across by 5, and you get x squared minus 4x plus 1 is equal to 0. And then now you would try to factor that, but I don't know, is that gonna factor? I don't think so. This would be kind of one of those simple factoring cases where we could look at, because there's a 1 here, right? That's what makes it easy. We could figure out what multiplies to 1 and adds up to -4. That definitely doesn't happen with nice numbers, right? So we're gonna have to use the quadratic equation, which is fine. So we're gonna have to use that. I'm gonna go ahead and, erase again so I have some space. That's why I like to use the document camera in class, because I'm not a huge fan of erasing all the time. We had x squared minus 4x plus 1 is equal to 0 is where we left off. All right, I'm gonna try to stay away from the lights. Sorry about that. If we use the quadratic formula, it's going to be x equals, negative b, which will be positive 4, plus or minus the square root of b squared, which will be negative 4 squared, minus 4 times a, which is 1, times c, which is 1, all divided by 2 times a, which is 1. Okay, so what we get here is 4 plus or minus square root of, that'd be 16 minus 4, which is 12, all over 2. And then you want to reduce that, all right? Okay, so 12, right? We're going to think about 12. 12 is the square root of 4 times the square root of 3, right? And we know the square root of 4 is 2. So we know this is 2 square root 3 all over 2. And so then we can divide this 2 in, we get 2 plus or minus square root 3. Alright, so we have 2 plus or minus square root 3. And those are the other two zeros that we're missing. So let's conclude this, alright? So what do we have? What do we figure out? I'm going to erase again. So what were our zeros? So the zeros were, I remember negative 2. And then was it 7/5? I think it was 7/5. I'm checking the calculator again. Because I don't have my work saved, right? So I have 7, can you see that? 7 divided by 5. Yep, okay. 7/5. And now we have these, we have 2 plus radical 3, and we have 2 minus radical 3. Now you can check those as well, right? So I'm going to pull the calculator up again. If we hit trace, you can check 2 plus square root 3. And this better be right, or else I'm going to have to redo this whole video. Square root, where are you? Why can I not think right now? Square root of 3. All right, I just typed that in. Enter, and you get your x-intercept right there. See it blinking right on that x-axis? Sweet! All right, and we could also check 2 minus, but it's gonna work. That always works out. So if we do 2 minus square root of 3, there's the other 0 right there. Beautiful. Okay, so those are the zeros. I don't know, what did the notes ask for? I wrote the notes, right? So what did I ask for? Oh, okay, find the zeros and write it in factored form. So for factored form, P of x is gonna equal, it's always gonna be x minus whatever these zeros are, right? It's always x minus. So it'll be x minus negative 2, but what's x minus negative 2? Minus negative, does not turn into a plus. Minus negative. So we get x plus 2 to give us that 0. X minus 7/5 for that one. X minus 2 plus radical 3, and then x minus 2 minus radical 3. All right, now notice that I have these extra parentheses here, and that's important because you're making sure you're subtracting the entire number. In addition to this, whatever the leading coefficient was of the original polynomial, that needs to go in front here, okay? So the 5 needs to go in front so that if we multiply this all out, we would actually get back what we started with. Okay, so this is our factored form, and that completes the problem.